GATE 2013 Civil Engineering Question 27. Find the magnitude of the error in the estimation of following integral using Simpson's 1/3 rule. Take the step length as 1. The integral is given as lower limit 0 to 4 x to the power 4 plus 10 dx. The answer needs to be found rounded up to 2 decimal places. The relevant NPTEL reference has been cited. If we want to integrate a function fx from a lower limit a to a upper limit b, so let us assume this is our function y equals fx and it needs to be integrated from a lower limit of x that is given as a and upper limit of x that is given as b. So usually we do the mathematical integration that we have studied in our higher secondary, but a technique that is utilized in engineering mathematics is numerical integration. Here the area under the function is divided into small segments of width h. H is given by b minus a divided by n, where n is the number of such segments of width h. So using the rule of Simpson's 1/3, we can find the area under the function or its integration. So what Simpson's 1/3 rule says is that if we want to integrate from a to b a function fx dx, we can do it, and it will be equal to h by 3, where h is the value b minus a by n into the first ordinate plus the last ordinate. So the first ordinate will be y of 0 and the last ordinate will be y of n, plus 4 times the sum of odd ordinates. So that would be y1, y3, y5 and so on till the end, plus 2 times the sum of the even ordinates, that would be y2, y4, y6 and so on till the end. It is to be noted that the first and last ordinates should not be counted in either of these sections. So in this case the integral that is given to us is x to the power 4 plus 10 dx and the limits are 0 to 4. It is said that the step length should be taken as 1. So using the Simpson's 1/3 rule and indicating the integral by is, it will be equal to 1 by 3 into first plus last plus 4 times the sum of the odd ordinates, that would be y1, y3, y5 plus 2 times the sum of even ordinates, that would be y2, y4 and so on. So we will make a small table to find these values. So the value of x would be 0, 1, 2, 3 and 4. The corresponding values of the function y, which is equal to fx, that is x to the power 4 plus 10, would be 10, 11, 26, 91 and 266. So the first ordinate would be y0 and then we would go y1, y2, y3 and y4. So here we will substitute the values. So the first plus last, so that would be y0 and y4. So that would become 10 plus 266 plus 4 times the odd ordinates. So that would be y1 and y3, which are the odd values. So that would be 11 plus 91 plus 2 times the sum of even ordinates. So here we only have one even ordinate, that is 26. So 2 times 26. This value would turn out to be 736 divided by 3, that would become 245.33. Now we will find the actual integral IA. So that would be integral 0 to 4 x to the power 4 plus 10 dx. So the integration of x to the power 4 would be 1 by 5 x to the power 5, the limits from 0 to 4, and the integration of 10 would be 10x, where x is from 0 to 4. Substituting the values, we would get 4 to the power 5 by 5 plus 40, which would turn out to be 244.8. The error magnitude can be calculated as the difference of IS and IA. So it would be IS minus IA, and we will take mod as we just need the magnitude. So substituting the values, 245.33 minus 244.8, which is the actual integral, the value would turn out to be 0.53, which is the error in the integration. So the magnitude of error was found out as 0.53. The relevant NPTEL reference has been cited.